So I've been through this by hand. I will show you how to use your calculator to help back up these skills in this video. But it is important. You won't be able to use your calculator very well unless you kind of understand what parts of the equation represent. So reminding yourself again about the number that goes with the x variable is going to be your gradient. That will be your rate. And that the constant out the back is going to be your y-intercept, and that is your initial amount, and also using the graph to read these things as well. So the first question, they ask us to find a rule and of the relationship here. So to do this, you need to pick 2 points on the graph. So I'm going to pick the first point because that's easy to read. And again, points always come as x comma y. Don't get those reversed. So that first point will be 0, 30,000. And then I'll look at another point. It could be anyone on the graph that you want it to be. And maybe I'll use this one, 50. So that's going to be day 50 and 25,000. And let's put those into our calculator. So we're going to go to Stat. And you enter in your points, make sure they go in as pairs. So 0 and its y value of 30,000, they go opposite each other. Then you'll have 50 and 25,000. Next thing we'll do is graph 1. See, those are my 2 points. It is decreasing, kind of looks like the graph that I have. Calc. This is a linear equation, so I'll use the x because I know it is linear. Again, on your calculator, you'll want to hit F1 one more time before you see this screen. And now we can write our rule, given the information we've got. Now, from the calculator, it gives it to us as y equals ax plus b. That's similar to the y equals mx plus c, and just be aware of that. So y is equal to ax plus b is what the calculator gives us. Similar thing though, this is the gradient, and this is your y-intercept. And if you look at the calculator, you just need to substitute in what they are. So my a is negative 100, and my b is 30,000. So I would get y is equal to negative 100x plus 30,000. And I would want to put it into the context of this problem, being aware that I see d and w instead of x and y. So I'll replace the x with a d, and I'll replace the y with a w, and I'll leave everything else the same. And so that is my equation into the context that they are looking for. Right. So how much water is there initially in the reservoir? Well, you could use table or graph to do that, but we can also just look in this case at the graph. We can see initially at the very first day, day 0, at the very start, there's 30,000 liters. And I can also see that from my rule, reminding myself that the y-intercept, the plus 30,000, that is my initial amount. That is what I'm starting with, or my flag fall, or anything like that, depending on the context. So I know it'll be 30,000 liters, and make sure you put in the units. If I wanted to show that using table, just to do that quickly, I would go back to table on your calculator, enter in my rule, and again, I only need to put in the stuff after the equal sign, so I'm going to say negative 100. Instead of d, I will use the little button under the red one there, that x button that I always want to use for my variable, plus 30,000. Hit table, and you can see that it's going to be hard for me to read here, because it only goes from 1 to 5. And what do I actually need? Well, I can use my graph to help me figure that out. Look at it. It goes from 0 to 200, and what is the step size here? 0, 10, 20, 30, 40, 50. So on my calculator, I'll go exit backwards 1 to set. I want to start at 0. I want to go to 200, and I'm going to use a step size of 10. Go back to table, and I can see at 0, at the initial, there's 30,000 liters there. The next question is asking me when will there be half the water? Well, if I started with 30,000, what's half of 30,000? Divided by 2 gives us 15,000. So when do I have 15,000 liters? I can continue to use table, go over to the Y column, because that's the amount of water, and scroll down, until you see 15,000, which happens on day 150. So that would be one way to solve for it. Another way would be to look on the graph. 1500 happens on day 150. But what I do want to show here is show substitution, because even if I'm using my calculator, I still need to do this. So that is when my water is equal to 15,000. So water is equal to 15,000. Look at your rule. Replace the W with 15,000. So 15,000 is equal to negative 100D plus 30,000. And then you can just write D is equal to 150 days. So you need to, at the minimum, show your substitution and make sure you get your units. How many days will the reservoir last for? Well, what's that mean? That means I've got no water, so when water is equal to 0, again, show our substitution. That 0 is equal to negative 100D plus 30,000. Of course, you can use algebra for this, but if you're not confident with that, let's go and look and see if we can find out when there's 0 water left. Now, I've only gone to 200 here, so I don't have enough information there, but if I remember, exit backwards, go back to set. Let's bump that up to 500. Just take a guess of some big number, and let's see if we can find 0. So, go over, and we can find 0 happens on day 300. So here, then, because I've shown my substitution, I can just write D is equal to 300 days when there's no water left. So again, that was using table. What is the rate of water loss per day? Well, I can't really use my calculator to help me with this any more than it already has. I have to remember that the rate is my gradient, that I'm losing, going back to my equation, a rate of 100 liters per day, because that's negative 100. So 100 liters per day. Oops. And remember that it's per day because my units are day and liters on the x and y axes. To write the equation for the second reservoir, again, this is going to be tricky for us. Probably the only way to do it is without the calculator. So we have to just pay attention to this idea here, like we did in the first time I went through this, that it's got half the rate, so its gradient will be equal to negative 100 divided by 2, which is negative 50. And its y-intercept would be 30,000 minus the 25,000. Which, oops, sorry, it's 5,000 less. 5,000 less, which gives us 25,000. So my equation, I would just have to change my gradient and my y-intercept. And now that I have that equation. So, next thing that we can use for finding when they have the same amount of time, remember this is when we're looking for the intersection where the two lines cross. So the intersection using your calculator, couple of ways to do this. I can do this in table if I just enter in the second equation, negative 50 x plus 25,000. So I can put more than one equation in, go to table, and I'll see them both show up there. So y1 is my first reservoir, y2 is my second reservoir. And I could just scroll through and look to see if I can find when they have the same amount of water. And I'm also going to, yep, there it goes, day 100. So on day 100 I can see they both have the same amount of water. But how I'd want to show that is that I'm going to set my two equations equal to each other. So I would say negative 100 d plus 30,000 is equal to negative 50d plus 25,000, and d is equal to 100 days. And again, you could go back up to the top as well and look at that on your, oh, we haven't plotted it yet. Oh yeah, we're supposed to plot it. Okay, so we're supposed to plot w equals negative 50d plus 25,000. So to plot, we can, like we've just done, put this into table. Reminding myself, I put in that second equation into table. If it's confusing to have two equations, you can delete the first one. You can also turn the first equation off by hitting select, and you'll just see one. I don't mind seeing both equations. For me, it's not too bad. I know that's the first one, and this is my second one. So I'm going to look for points that I can plot. Well, 0 and 25,000, that's pretty easy. I can go 0 on x and 25,000. And let's look at another point that's easy to plot. The 500s are weird, like the 24,500, that's weird. So I could go down, pick another big point if I wanted. How about, yeah, we'll do the 100. So on day 100, I know that I've got 20,000. It's the same as the other graph. And so I've got 2 points on this line, and using a ruler, of course, you can plot your second one and make sure that you label it, this being the first. So that would be my plot. And again, to see that intersection, I can see, oh, did I get that right? I didn't. That on day 100, those two graphs cross. But again, we can see that in table, and a second place to see this as well would be in graph and gsolve. So I could go to menu and go back to graph. My two equations are there. Now sometimes your calculator will error out if it's carried them from one function to another, like from table to graph or solver or anything like that. So you might just excuse me, you might have to retype your equations, but let's see if they're there. Yeah, so if it says condition error, it's just because your calculator is not as smart as it wants to be. You have to retype the equations in there. Draw your graph. Now it's important for you guys with your calculators, some versions will do this and some won't. If I can't see the intersection of the two lines crossing, it won't be able to solve it for me. So if you go to your view window, again that's F3 for view window, I can change my graph to match, my view window here to match what I actually see on the graph above, which was roughly 0 to 200, the scale of 1. And on the y I started at 0, and I went up to, let's say, 35,000 just to get above. And now I can see a graph on my calculator looks similar to the graph on my that we had on here. So if I want to find my intersection, gsolve is a very powerful tool. We can go to gsolve, ISCT, and it's going to give me the intersection between those two lines. And you can see that it happens at x equals 100 and when the water is at 20,000 liters. So that's another way that you can solve for intersections using your calculator. For how many days will the water last in the second reservoir? I could go back to table if I wanted to, but I'll show you another trick here in solver. So if I went to table, I would just go look to see when the second reservoir hits 0. But there's another thing I can do here. So this is w is equal to 0, and w is really my y is equal to 0, and it's my d's that I want to know, and d is really x that I want to know. So this is have y, want x, use xcalc in gsolve. I'll show you that real quick. So gsolve again, heaps of information there. I don't see xcalc yet, so I'll arrow over. There it is, xcalc. And it wants to know which equation I want to do that with. So I don't want to use the first one. I will scroll down to the second equation and hit enter. Now that you'll only have to make that choice if you have both graphs on there at once, but enter in the y value that we have. So what's the y value that we have? We have y is equal to 0 when there's no water. And this is a great situation of I haven't shown my graph. I can't see on my graph what I'm trying to calculate. So it's telling me it can't be found, but I know it can be. And the reason it can't find it, I'll just show you again, is because it doesn't show it on the graph, like the graph can't actually see it. So let's go to view window and let's change this out to like, I don't know, 600 days. We'll just make it really big. Leave y the same. And now I can see where it's going to actually hit the y-axis. So if I try that again, gsolve, look over for xcalc, I want to use the second equation for 0 when it's out of water, and you can see that it finds it for me on the 500 days at y equals 0. So I'd want to show my substitution by going 0 is equal to negative 50d plus 2500, and then I could just write d is equal to, what was it again, 500 days. What would the second when would the second river have exactly 1,000 liters more water stored in it than the first? That's a tricky problem, but one way that you could do that would be with a calculator, would be using table. Again, if you're swapping back and forth between functions, you might have to retype them. Zero to 500 seems alright. Steps of 10, table. And I want to know when the second graph is 1,000 more than the first. So I know that on day 100 they have the same, so I'll go to at least day 100. Here they've got the same. Now I want to try to find when is it 1,000 more. And I can see here that on day 120, y2 has 19,000 and y1 has 18,000, so that's where they have a difference of exactly 1,000 liters between them. So I would be able to use that for my answer. So you could write on day 120. And you'd have to show that somehow, so you'd probably want to think about saying something like negative 50d plus 25,000 is equal to the other one, which is negative 100d plus 30,000. But it's 1,000 bigger than it. So that makes the second one 1,000 bigger than the first one. And then you can use table to just give your answer. And again, I mean, in a pinch, if you don't know how to write this in terms of the algebra, that's fine. You're still going to get credit for part of it anyways, if you can use table to help you figure out where those numbers, where that actually becomes 1,000 bigger. So that's again showing you the same problem using the calculator for tricks. So try to get familiar with both, because it's helpful to both be able to do it by hand and be able to do it with your calculator.